Coral reefs are extremely beautiful and diverse ecosystems. They provide shelter for thousands of species as well as food for millions of people. However, corals themselves are extremely sensitive to changes in temperature. Because of this, climate change threatens coral reefs all around the world. But there is some hope. Some corals are more heat tolerant than others, and corals in the National Park of American Samoa on Ofu Island are among the toughest in the world. These corals survive temperatures that would bleach most other corals. But why are these corals so strong? One hypothesis is acclimation, and this means that corals can learn to tolerate heat by seeing increased temperatures on a regular basis. The focus of my work as a George Wright Fellow has been to understand the process of acclimation. The experimental setup we used was designed and built by Carlo Caruso, the park ranger on Ofu.
Several of the research groups were interested in doing precisely controlled temperature experiments on captive coral samples. This is pretty difficult to do because of the kind of equipment that you have to bring with you in order to control temperatures when the tropical sun is beating down on your experimental tanks. So we recognized that need and built a tank array that has temperature control and can control individually up to 10 different tanks very precisely and in a way that the researchers can program it to test their hypotheses about how heat stress and coral bleaching are linked.
We allowed corals to acclimate to different temperature regimes and then tested their heat tolerance. What we found is that corals that had been exposed to heat already were much more heat tolerant, meaning that they acclimated. This means that corals that already experience increased temperatures, like those on Ofu, are in a sense training for even greater heat stress in the future. The next portion of this project will be to explore the cellular mechanisms behind this heat resistance. We will use a molecular approach to understand what's going on inside the cell that makes corals more heat tolerant. Combining this cellular level understanding with the physiological experiments and the ecological context, we'll be able to better understand how corals will respond to climate change and therefore how best to protect them.